Assalamualaikum and good day, guys. In this video we are going to talk about the third chapter of EQT101, which is vectors. We have already touched a bit on vectors in our previous topic, which is on eigenvector, right? So let's recap a bit. What is vector? Okay, so vector is actually a mathematical quantity that has both magnitude and direction. Okay, if any number or any mathematical quantity that do not really contain both of these attributes, we cannot call it a vector. So basically we represent vector with an arrow, right? Just like what I showed you before in our previous chapter. When I want to show you a vector, I will show you a graph with an arrow within it to represent vector. So why arrow? Because they have a direction. That's why we need to have an arrow. Okay, so example of vector, we have displacement, velocity, acceleration, force, all of the mathematical quantity that can have both magnitude and also direction. So the other kind of mathematical quantity or numbers that only have a magnitude, or in other words a size, is called a scalar. Okay, so in this kind of mathematical quantity, we don't really have the ability to describe that number together with the direction, right? When we try to present the value of that mathematical quantity, it will only show us a magnitude, right? So example of a scalar quantity is mass, temperature, length, area, and so on. Anything that when you look at the value, you don't know what is the right direction, so that is known as a scalar. Now, as the notation for scalar, right, when you represent it in single letter, we will represent it just in italic letter, right? Italic, small, or maybe capital, but we don't really have this underline, so just please ignore it, right? We don't have this, so that is for scalar. As for vector, okay, we are also going to represent in we can represent it in a letter, right? But difference from scalar, we have a line under it. Okay, but sometimes some books put the line above the letter. Okay, so that is one way. The other way is to represent it directly by showing the point of 2 points that you have in vector. For this case, the point is A and B. So the arrangements matter. The arrangement here matter. So when you put A, B, it means that the direction is from A to B. If you put B, A, direction change, right? So AB means A is the starting point, or in vector we call it an initial point, and B is the ending point, or also called a terminal point. Okay, as for this one, when you change it, change the arrangement like this, BA, now B will become the initial point and A will become the terminal point, right? So that is vectors representation, and later you're going to see that we are going to calculate for magnitude of vector. When we say magnitude of vector, it literally means that we are going to calculate for the size. So how long is this vector? So to calculate it, right, we are going to just use the formula of modulus like we have in chapter 1. So it is not a new thing. We are going to revisit it later. And this is how you denote magnitude of vector. So just a vector notation with a modulus way of representing notation. Okay, now let's look at vectors negative, right? For vectors negative, and this definition 3.4 want to tell us about what happened when you multiply a vector with negative. Okay, so giving a vector a negative is one way for us to change the vector to the opposite direction. Okay, so for example, if you have vector A here, okay, or vector AB, when you multiply with negative, okay, so this is A to B, when you just input negative, automatically the direction with the initial and terminal point change. Right, now it becomes negative A, the direction changed to the opposite side, and B now become the initial point. Okay, so next let's look at 3.4. What does it mean when we say these two vectors are equal? Okay, because of in vectors we know that the two important attributes for vectors is that they have magnitude and directions. So basically, in defining two vectors are equal, also we'll need to look at these two attributes, which is magnitude and direction. If both of the vectors have the same length or magnitude and the same direction, well, it means that they are equal. Okay, so next let's look at the operations of vector. In this video we are going to look at maybe addition and subtraction. How do we sum and how do we subtract vectors? Okay, we are going to first look at it through graphic, right? So first, it can be solved for addition of vectors. It can be solved by using the triangle law. The name is triangle law because in order to solve it, you will need to draw a triangle shape. Okay, so let's say we have A and B, A with to this direction and B to this direction. So to sum it, simply combine these two lines, where depending on which one is first. For example, if they say A plus B, then A should be combined to B. So the terminal point of A should be combined with the initial point of B. So hence it become like this, right? Combining it without changing the direction. Yeah. So when you combine it and then you connect the initial point of A with the terminal point of B to get the new vector, which will have the new magnitude and the new direction. Okay, so next we have a parallelogram law. Okay, for parallelogram law, okay, this is just the other way for you to calculate, to sum between two vectors. So in parallelogram law, it talks about the parallel between vectors. So basically, just make these two vector parallel, right, to their other self. So basically, we are going to have another A and another B, make them parallel. So A with A and B with B. The line in the diagonal line here will represent the result of the summation between A and B. Right, as you can see, they should have the same answer. This is for triangle law. This is AB, and this is for parallelogram law, which also should have the same magnitude and direction. Right. So that is if you sum it by summing two vectors. Now let's see how to actually sum more than two. Okay, so let's say you want to sum A plus B plus E, three vectors. So the concept remains the same. Right? Previously we did know that A plus B equal to the initial of A connecting to the terminal of B, given the new line, the new vector here. The same goes if you want to multiply more than 2, A plus B plus E. So we are going to connect A to B, B to E, and the terminal point of E will be the last point. Okay, so we are going to connect initial of A with the mean of E, which will give us D. So D here will be the new vector, right, as a result of summation of A, B and E. So as you can see, it has a new magnitude and a new direction. Okay, so try to make sense a bit, right, on what does this really means. When you plus A and B, you'll get this new direction. Okay, let's try to make sense of it a bit. So let me pull out a picture. Okay, let us try to look at this example, right? This is, for example, vector A, and this is vector B. So as you can see, if you sum with these two, right, this the airspeed of this plane with the wind velocity, right? So we have aeroplane moving this way, wind blowing this way. Okay, where will the aeroplane direction will be? Right, the aeroplane will not, of course, will not following this route, because it have a resistance from an air, wind. So just imagine that while the aeroplane try to move this way, wind also blowing this aeroplane this way, which will make the movement of this aeroplane to be not just a straight line like this. It will be somehow drifting. So instead of going this way, this aeroplane actually moving this way, right? It is just like it's just imagine this is an aeroplane. It is not moving like this, it is drifting, because it have a resistance from a wind. So there is one way to use a vector to find out what is the actual direction, right? When we try to consider the two directions with their strength of the direction, the magnitude, we can figure out where is actually this aeroplane go. Right? By right, if there is no wind, yes, the light, this aeroplane will go straight like this, right? Because now we have a wind, so the aeroplane move like this while being pushed by the wind. Give us the result of this direction. So basically, this is how to make sense of the summation of vector. Alright, so in the next video we're going to talk about other operation, right? Okay, so thank you.